Okay, today we're going to talk about factoring special cases, and that's what today's lesson is about. So let's dive right in. Okay, the first main idea is this is going to be called difference of perfect squares. Difference of perfect squares. Now, we're often just going to refer to this without the word perfect as difference of squares, but every time you hear me say difference of squares, I'm actually referring to the difference of perfect squares. So when I talk about squares, I'm referring to perfect squares. So on your formula chart, we have a squared minus b squared, and this is going to equal a plus b times a minus b. So let's talk about a few things. Let's write down a few things about this pattern here that's pretty important. Number one, a squared minus b squared is a binomial. So we're starting with a binomial, and it factors into two binomials. It is the only binomial that's going to factor into two binomials. The next thing that I want to make sure that we point out is that both terms are perfect squares. Both terms are perfect squares. So a squared is a times a, b squared is b times b. Then whatever the square root of that is, whatever multiplies to get that is going to go front. So a times a is a squared, b times b is b squared, and that'll make more sense as we go through our examples. But I do want to write one more thing down, and this is a little catchphrase that I like to use. And that's going to be with difference of squares the signs are different. With difference of squares, the signs are different. And that just means that one's a plus and one's a minus. Technically, they're opposites, but I like the word difference and different because they're related. So the difference of squares, the signs are different. Also, it is difference of squares, which means subtraction. It's not addition, so you do have to check out and look for that. Also, one thing I do want you to always remember is whenever we're factoring, you can always check by multiplying or by distributing. So let's just put multiplying. Check by multiplying what you have back out. Okay, so let's look at some examples with this. The first example is going to be c squared minus 81. C squared is a perfect squared. 81 is a perfect square, 9 times 9, and then we have subtracting. So that is difference of squares, so we can just look at that and know that it's going to factor what times itself equals c squared? C times c. What times itself equals 81? 9 and 9. And then with the difference of squares, the signs are different. So one is a plus and one is a minus. It doesn't matter which is which. I typically put the plus over on the left and the minus on the right. Okay, now remember we can check these. So let's just do a quick little check. If we multiply it out, we get c squared minus 9c plus 9c minus 81. What's going to happen to our middle terms? They zero out. So they become 0, so it's just becomes c squared minus 81, which is what we started with. Now, those opposites are what make it 0 out. So technically, we could write this as c squared plus 0c minus 81 and use the star method or a different way. But just know that this is just a shortcut, a special case. This is something we will be using all year long or for the rest of the year, and it's not going to go away when you get into high school. Okay, so example 2. Let's look at this one. 16 is a perfect square, h squared is a perfect square, and 9 is a perfect square, and a squared is a perfect square. So everything we have in here is a perfect square, and we have subtracting. So this is the difference of squares. So that is automatically going to go into our two binomials. What times itself equals 16h squared? 4h times 4h. What times itself equals 9a squared? 3a and 3a. And with difference of squares, the signs are different. So one is a plus and one is a minus. I'm not going to take the time to multiply that back out, but if you do, you will realize that it works. Okay, let's jump to example 3 now. For example 3, wait a minute, we have 2. 2 is not a perfect square. U to the fourth, is u to the fourth a perfect square? I will say that if the exponent is an even number, then it's a perfect square, and it's going to be half of that times itself. So if we had like u to the sixth, half of that would be 3, so that would be u cubed times u cubed. U to the third times u to the third equals u to the sixth. And this doesn't, so we've got one perfect square in here, and it is subtraction, but the others aren't. What do we always need to make sure that we do first, if we can, before we start factoring? Yes, look for GCF. So let's write this down. GCFs with a question mark. In this case, the GCF is 2. So that's going to equal 2. And then let's factor it out. If I factor a 2 out of this, I'm left with u to the fourth. Minus, if I factor a 2 out or take half of 162, that's left with 81. Oh, look what we have right here. We do have the difference of squares. So let's take this. So this is going to be 2 times, let's break it into our two binomials. What multiplied by itself equals u to the fourth? That's going to be u squared times u squared. What multiplied by itself equals 81? That's going to be 9 and 9. Difference of squares, the signs are different. Okay, so there we go. Now, whenever you're factoring, you always have to make sure you fully, completely factor. Just like whenever you reduce fractions, reduce it all the way. This is the same way. So if you can factor something further, you need to. So here we have a 2, regular number. We can't factor that any further. At least it's not going to help us. U squared plus 9, that would be, u squared is a perfect square, and 9 is also a perfect square. But because that's a plus sign, we can't take that any further. But right here, we have difference of squares again. We're subtracting, and we have 2 perfect squares. So I'm going to just write down what we have here in the front, plus 9. Now this second one is going to factor further. So I'm going to put 2 sets of parentheses. What times itself equals u squared? It's going to be u times u. What times itself equals 9? It's going to be 3 times 3. And difference of squares, the signs are different. And now it is completely factored, and you cannot go through it any further. Okay, we have 4 more examples to do, but we have another main idea here, and this is factoring by grouping. This works when we're dealing with 4 terms, and then we have 3 basic steps here. The first thing we're going to do is we're going to group together the first 2 terms and the last 2 terms, and as we go through the example, it will make sense. Then we're going to factor the GCF out of each group. When you do that, you should be left with the same thing in the parentheses, and that'll make sense once we actually do an example. And then for 3, we're going to factor out the remaining GCF, and that'll make sense too. So let's go through that with these. So first, we're going to group these 2, and we're going to group these 2. Then we have to figure out the GCF out of the first 2. We have 4QR and 8R, so 4R is the GCF of both of those. Once I factor out that GCF, factor out the 4R out of this first one, I'm left with the Q. Factor a 4 out of the second one, I'm left with 2, so that's going to be plus 2. Then we're going to do the same thing with the last 2. I can factor a positive 3 out. If it's positive, put a plus, negative, put a minus. And here I am left with Q plus 2. Okay, so that was step 1 and step 2. Now, if you notice, we do have something that's the same. So now we're going to go back to this whole entire thing, which has this term now and this term. What's the GCF I have in common in both of those? They are the q plus 2. Then I'm going to factor the q plus 2 out and put it in the front. When I factor the q plus 2 out of this part, I am left with 4r. When I factor it out of that one, I am left with the 3, and that is our answer. So again, you factor out the GCF first, which was the 4r, and in this one it was the 3. We want to make sure that we have the same thing in the parentheses, and that's one of the things we're going to talk about over the next 3 examples. And let's go to the next video.